bit for everybody to come in. Yeah, number 6 or 2026. That's my new way of looking at this. Yeah, we're gonna start by talking about everything that's coming up in the next major release. So one thing I wanted to remind you all is the way we do version, because it gets confusing sometimes. But because it's a major framework, we can't really do, first number is major breaking API, second is minor non-breaking, and last one is micro little details, because there's just so much entanglement in the different operators that what we do is really the first number is like major paradigm shift. Number in the middle is when we break things, or at least add new API, change API, if you would rather say. And then the last number, we're hoping that within the 2 point something, everything after that is as stable as we can. So the last one was 2.4, and the next one is 2.5. Yeah, the last one was mostly a rewrite of internal stuff. 2.5 has some front-facing interesting things. So let's go through it. Yeah, that's what we're gonna talk about today. Just take a minute to read it, but I'm gonna go over all these things, and it kind of goes from the more benign to the more quote unquote exciting, perhaps. So yeah, let's start with the language quality of life. So what we mean by that is that we are hoping to enhance the way people use the script, because we're very well aware that there's a small Venn diagram intersection between people who do radio and people who do programming. And you still have to do programming to use Liquidsoap. And so every time we try to like think about, what is the perspective of a user that's not a programmer. And there's a couple of important and less important things. So let's start with this, which was an idea by Sam originally. It's been floating around for a couple of years and was finally merged. The idea is that if you remember well, in our typing system, we kind of say, oh, an integer is different than a floating number. And it's kind of important, you want to know that. But it adds burden on the user because they have to know. So one of the things we do now is every time there's something that's easy to guess, like if this duration is supposed to be a float, but you're passing an integer, well, we should be able to say, okay, that's cool. Like I know how to convert an integer to a float, so I can accept that. So we're gonna accept integers in the easy cases when it's clear there's no ambiguity. We're still gonna refuse them when there is ambiguity. Like if you have a list that has both integers and floats, well, we don't know. So in this case, you're gonna have to specify or change your values. But yeah, that's a little something. Same thing when you write your script. Sometimes you need to say, this thing is supposed to be a getter, a reference, and up until now it was very annoying to do. So now you can do this type annotation easily. And we try to improve runtime errors. One of the things we added is a stack trace. So that source is valuable. It tells you that, right? But the thing it doesn't tell you is when that source is used. That's one thing I realized, like, because the error is going to come from an output. So now it's going to be able to tell you, like, this is the source, but it's also, you look at the stack trace and you got to point to where you're using that source and what kind of output is saying this source is valuable. So you can trace your errors more easily. All right, quick on OCaml5 and multicore, because that comes a lot. OCaml5 has a lot of functionality for multicore, meaning that you can run things in parallel over the different cores of your CPU. But up until now, we haven't been able to use it because when they put the new OCaml, there was some regression on the pacing, meaning that memory accumulated too much. It's not that it was leaking, it's just the garbage collector was too slow. And the nature of our application is that it does a lot of very quick allocation that needs to be cleaned, because remember, we do like streaming loops every 0.02 seconds. And so the GC was just being like, whoa, what the hell, this is too fast for me, and just growing too much. So it's been tracked. There's a fascinating talk by Jane Street founder here, the saga of multicore OCaml. I recommend it if you're interested, because it was a fundamental problem with OCaml, and they tracked it. It should be fixed. So they're progressively merging it back into the compiler, and my guess is by 5.5, we should be able to switch to it, or at least try testing it more seriously. Um, but one thing to keep in mind is multicore for Liquidsoap is a bit tricky because a lot of the things we do is sequential, right? If you think about your script, you have an output, it fetches a frame from the operators one by one, and comes back, then sends the frame to the different destination, and that is not really something you can parallelize easily. But for us, what it really means, and that's kind of more of a niche thing, is that if you are running several outputs that are independent, then you might be able to use multicore. So what I'm trying to say here is that one of the reasons this hasn't been really a major missing point is that for most people, they only have one script. And the parallelism will come in part through the encoder and decoder, which is where you really are CPU bound. That's where the most work is being done. And that is already there because it should be encapsulated by FFmpeg typically. We can do that on decoding and encoding. All right, so another thing that has happened that I want to talk about is there's some major performance coming up, and it all started with a bug report. We had a user who say, hey, our CPU is climbing. And we investigated it. And what was happening is that there was a leak, an accumulation of sources. That it's one of the scripts where they do a lot of dynamic source allocation, and it was not properly collected. And so memory accumulates, CPU accumulates, all that stuff. But the thing that was interesting is, as I said, pretty often when you're debugging, if it takes you a while to get to your bug, one of the side effects is that you get to clean a lot of things. And so what happened is that when we started having performance report showing all this heavy CPU usage, it also started showing all the hotspot, all the parts of the code that were being repeatedly called over and over and over, and that's the part you want to optimize. And so we discovered a couple of things. I can go into details, but essentially through that we were able to optimize the way we check for synchronization source, because it was being pulled on the whole source graph every cycle, and that rarely changes. So you can do the other way, meaning that a source that changed notifies up, and then you only need to process when it has changed. We also noticed some very serious optimization on the way we measure the content length. Not going to go into details, but all of that was optimized pretty nicely and resulted in a pretty good CPU drop on even normal scripts. And that is on 2.42. We'll do a backport release of that. But we're not done. I wrote that slice being too optimistic. I thought I had it. Still debugging with the user. So as soon as I have confirmation that we fixed the bug, I'll do a 2.4 stable release with that, and this is already in 2.52. Another thing I've done, I'm going to go fast because I want to focus on the other stuff. I'm in the process of rewriting Jack. I just realized recently that our Jack integration was very old, and he was not using the new clock system. And Jack is a perfect example because Jack has an internal thread, and that thread drives time, and it also is very, very short latency. So with the new abstraction we have for clock, now we can say, Jack, let your callback be the driver of our time. And also let's try to be as short as we can to see how far can we push latency on new model, which is not guaranteed we might be able to. I need to go back to it. It's not finished. It works in 20 millisecond, in 0.02, it works in 20 millisecond. I don't know if it's going to work in like 5 millisecond like Jack stuff, but we'll see. All right, subtitles. Now we're getting to the big new feature. This one is already in. It was itching for a while to do it. I'd say that subtitles is not necessarily the most thing that you would think about as a user, because I think most of our use cases are more like radio or radio with video typically. So why subtitles? Well, first of all, we're trying to get on parity with FFmpeg, and that's the last type of stream that FFmpeg has that we were not properly supporting. I also think that for us as developers, we wrote the whole content layer in 2.3 or 4, and it was a nice way to just try it, to say, is this new abstraction that we've done for content a good idea? So yeah, we have it. We have a native decoding that Sam wrote using the text format SRT, and we can do subtitles. The other decoding we have is true FFmpeg. There are two versions. the same way as we do for audio and video. The subtitles with nothing is actually a full decoder. So if, underlying for subtitles, you have bitmaps, which are images or text. I believe that only text can be decoded through the subtitle because what's going to flow once it's decoded is actually a text value that you can manipulate. Remember that we have a lot of functional operators, so you can do a mapping, you can insert them, you can react to them. So that's going to be your main subtitle decoder. Or you can do copy, which is the same way that works for audio and video, meaning that um, we're not going to touch anything. It's going to come through as an opaque FFmpeg packet, and we don't touch it. But that's where the bitmap is going to flow, all this good stuff. What can you do with it? Yeah, why it matters, because we want to be in parity. So what you can do with it is typically you can receive them or you can insert them. So that, remember that as functional, we have this operator, the subtitle.insert. And so when you have a live source, you can at any moment add a new subtitles right there, right now. You can map them, you can do all sort of stuff. Is it going to be useful? I don't know. It's there. It works. I feel like, I don't know, I imagine that the kind of use I could think about would be if you do a Twitch live stream. Typically, I think we have people doing that right now. One thing you could do is hook an API that can read a chat, for instance, or can connect with messages and insert them in real time into your stream. So the kind of stuff like that is pretty nice. Now we're gonna get into like probably the biggest biggest change that's coming up, and it's been going on for a while. And part of the reason is I want to engage with feedback from users because this is a pretty big change, but I do believe that it's really aimed to help people. So don't be afraid of change if change is things that are way overdue, even if way overdue means a lot of years. So this is the typical work that everybody does when you do Liquidsoap script, is like dynamic switching of source. You have a music source right here that's like a playlist of files, and you have a live that's like a harbor. You have a backup that's usually a single, and it's there if everything else fails, right? But the logic for that is completely different. If you think about it, when you have a live source like harbor, you need to play it right away. If your DJ starts connecting and start their show, you don't want to say, "Oh, sorry, wait until the current song finishes so you can start talking." No, you want to switch to it right away. Otherwise, you're going to start losing the first introduction of the show, which is the most important. Hello, my name is. Anyway, so the logic for going to live should be don't wait for tracks. It's the track sensitive files, you see it. But the logic for going to music is different, like music can wait. It's a file on a hard drive. It can always be delayed. You're not going to lose anything if you wait for the next track. Like, let's imagine that instead of a fallback, you have a switch, right? At 2 p.m. you play that playlist. At 3 p.m. you play that playlist. When the 2 p.m. slot ends, you can wait for the end of the track, few seconds, and then switch to the 2 p.m. playlist without cutting the end of the track. Don't need to get too much for that. But up until now, that whole logic was expressed with track sensitive equal files, but it's the same for like both live and music. So if you have a mix of those, and that's a fallback, but it's even more relevant if you have a mix of those in a switch that is time-based, let's say at 2 p.m. you switch to a live thing, at 2 p.m., you couldn't really do arbitrary mix of those things. And also it's expressed at the top level. But what we really want to say is that this source here, music, can wait, sorry. This track here, this source here cannot wait. So why express it at the global level when it's actually something you want to attach to the source themselves? And the second thing is transitions were always complicated because they don't work the way you think they work. Like fade out doesn't really work. If you switch out of a live source, right? Think about it. The DJ disconnects, you're like, whoop, I'm out of data. Let's go back to music. Whoop, I'm out of data means that, well, I don't have data. So you can't really do a fade out. And it's been one of the things that user kept asking us. So the reason I'm describing all that is those questions have been coming over and over and over. Why is my source not cutting in right here? Why is my fade out not working? All this stuff that, and after a while, you have to say, we have an answer, but is this answer the right thing you should say, or do we need to go back to the drawing board and find a better solution? So here's the proposal here, and we're going to go through it. The new model that we're proposing is two things. First, we're going to say every source can be a live source or a file source, meaning that it's a live source or a file source. Pretty natural, right? So it's a harbor input. It's something that's like it's coming in right away. It needs to be consumed. An ALSA input, microphone, live source, playlist, request queue, all of that are files. And so now we're capturing what I was talking about. Live source probably should be cut in immediately. Music, you wait for track boundaries. So what's going to happen next is that in your fallback or your switch, you don't even need to say track sensitive anymore because it's inferred by this. If you're switching to a live, if your live source starts, we need to like switch right away. That's fine. But if you're going between two file source, implicitly we'll be like, okay, we can wait for the end of that track. It's fine. Now, granted, don't put a 1 hour track in it, but for most of people, that's what they would expect out of the box. And the other thing, yeah, so this is the default. We want the default to be easy for users. And then how do you change it, right? If the default doesn't work for you. So top level, you can say, that's not the way that works. Typo here. There's a way to say the source is composition type. It's not track sensitive. Sorry, it's the old one. It's composition type live or composition type file. And you can attach the whole meaning to the whole source and say that source, let's say this input.harbor, I want it to be composition type file. You can set it as a little reference. And then you can also change the transition. So the default transitions here is going to be doing a short fade in and a fade out if it's available. And you can also change it by attaching an onSelect method to the source. There's a lot of parameters. I won't talk about it. Lastly, remember, one thing that people kept asking too is, oh, I want to skip the track on music when we go to live, so it comes back to fresh track. And that also was sort of a lot of annoying pain for users. So we've also made it easier by saying there's an onLeave method, and it receives the source, and you call skip, and that's it. It works. And also, by the way, that's the default now. So if you are switching to a playlist away, it's going to call skip on everything that's a file when you're switching away, so that it always starts on a fresh track. Again, we're really trying to like tap on everything that users have been having issues with for a long time. Yeah, that's why we're trying to make it easy for default for users. We're giving the tools to like override it when you want to do your own things, but by default it's going to be simple. And when you override it, the logic for it is also embedded nicely. Like you just have to say, oh, this is when I do when the source is done being played. What is important here, remember, is that you want to skip after the fade out. And that was always very confusing to say, well, when is the fade out over? But we've done it for you. Now we're gonna give you this callback, and when it's executed, the source is not played. It's being left. And so again, we're just making it. We're extracting what's really valuable and removing the complication abstraction. All right, I got just enough time to talk about the other big deal. And this one, maybe a live demo, we'll see, but drum roll. Yeah, one of the things that has been a pain for a long time is not a pain, but the relationship between Liquidsoap and Icecast is interesting. And we've had input.harbor, we've had output.harbor. A lot of people are using output.harbor, but it was old code. And I was not very comfortable. And also I was like, we could do something really nice here. And so, yeah, we started the experimentation of having a native Icecast server. And the idea is really an Icecast server, meaning that you connect a source using the Icecast protocol, which now is a straight HTTP for the most recent version. And it just shows up as an endpoint on the other end, on a web endpoint that you can point your listeners to. And if you think about it, what it really is a dynamic connection between input.harbor and output.harbor. Like in the script side, what it means is that we have an input.harbor that gets a dynamic endpoint. When you connect to it, it fetches the endpoint you're using, and it dynamically creates an output for it. When you disconnect, you remove the output. That's what Icecast does, essentially. But yeah, and it should work simple like that. Put a port, put a password, done. You can use it. But the one extra thing that's really nice is we also trying to be backward compatible with Icecast itself. So meaning that a lot of people use an XML configuration for Icecast. So we're gonna try to parse it ourselves. And so because it's not possible in the script, even though it's kind of annoying because it's really hard to read, but it works. And so yeah, we can do like the listen socket, the source password, a lot of those good things we support. We might support these, and we will not support that. And I might not have, yeah, I'll brush over it. But the idea is not to support every single feature of Icecast. It's just to support the ones that make sense so that we can easily prop one up using the configuration you're used to already. Yeah, you can have event, you can know when a DJ connects, disconnects, all this good stuff. So let's talk about why it's different from an Icecast server and the kind of benefit you can have in a Liquidsoap Icecast clone. Let's start with the fallback, right? So in Icecast world, if you have listeners that are connected to a given mount point, and that guy, the mount point, the source client disconnects, you can have a fallback, right? Meaning that you need to have another thing connected, and every single connection is going to be switchover, meaning they have to reconnect, and your stream is going to be interrupted. It says, oops, reconnect please, and it actually reconnects to the fallback that's under it. And then what happens when the mount point comes back on? Not clear, because you have to remember every state that was before it. So it might not work the way you want. And also there's interruption in the signal. With Liquidsoap, we can do something very different. That's awesome, is remember that we are operating at the stream level. So when you have a fallback, so imagine you have your listeners, they go here for the main point, and you have a fallback behind it. Well, we can use an actual fallback operator, meaning that the final source they have is a fallback between the two. So when this one goes away, it switches to this one. Inside Liquidsoap, nobody's disconnected. It's just a straight up fallback operation, right? And when it comes back, the fallback goes back to it, and nobody's disconnected. So there's no interruption when there is a fallback from the original mount point to the default one. B, it can go back to the original one when it comes back. And that's already a pretty big deal. But there's something more to it that is more experimental. So all of that we're hoping to be able to make work within reasonable bound. The one that's experimental, but I hope we can make it work at scale. So the problem, because the challenge now that we have the basic code and it seems to be working, is how do we test at scale? Right? I've tested it with Gilou and put 5 listeners, 5 endpoint, but how do you scale up and with confidence that it scales up? I think we're gonna have to have some trial and errors here. But one thing we're trying to do is a dedicated encoder. And by this, I mean that normally in an Icecast situation, you have one encode and an encode is shared. Everyone is reading from the same encoded stream, right? But that creates a lot of complication. Typically in OG streams, you have to start in the middle of a track. The timestamps, everything is weird. So what we're trying to do here is, it's called dedicated encoder, but really what it is if you use it with the copy thing we do with FFmpeg, it's a remuxing. We're going to receive the encoded audio and video, and we're going to remux it for every client into a new container. And if you keep that in mind, encoding is a lot of CPU bound. Remuxing is not very expensive for CPU. So we're hoping that it doesn't cost a lot of extra CPU operation to basically repackage the data that's already encoded per listener, but that would give listeners a clean stream that starts from the beginning. So that's the second big feature we're trying to develop with it. It's a challenge, we have to test it. I gotta skip a little bit because I'm almost out of time. But yeah, so that is out, can be tested. I would love to get some feedback or some people interested to like be like beta reviewer. I think it's beta status, meaning that it's ready for testing, it's functional. We need to make sure it actually scales up. All right, the last thing I'm gonna go real quick is I know it's long overdue. We need to do the book. And one thing that's cool is that because 2.5 is bringing all these new features, it's the perfect time to update the book, to follow it. So we definitely are committed to working on it. We've started working on it, and we're going to finish it for 2.5 to go along with the release. And if you're interested, at some point, we'll need people to help us reread it, tell us what works, what breaks, more eyes on it. That's it. That's everything we talked about today. That was a lot. I hope it was interesting. And yeah, we could maybe do quick questions, or we can try to keep the schedule as in time as we can for the next speaker. And thanks everyone for being here.
I had a question maybe for the hi, by the way. I had a question about the source composition that I didn't bring up when we talked about it. I wondered if the on blank default behavior was somehow incorporated, or we just have to add some skip blank, whatever the operator was.
It's not incorporated actually. That's a good question. What do you think it should do?
I don't know. By default, I guess people would like on blank to skip for live and music, like easy. And then maybe you can override it if you had like longer blanks, or if it's on purpose, I guess.
Yeah,
Because
we can
as,
do
as
that.
soon as I tried whatever you offered for the composition, because I tried it. Yeah, I know I'm not really fast, but I did. And that's the first thing I had to add to the boilerplate thing. It's like, yeah, because
Yeah,
sometimes,
I
yeah,
imagine the way we would do it is we would put a setting that says default on blank threshold, and by default, meaning 2 seconds, 3 seconds, it would issue a skip and move on. Yeah, we could definitely try that for sure.
because like when
Cool.
I tried it, like the first thing I had, like if I didn't have curated playlist, the first things I had to had was this, and it was everywhere.
Yeah, yeah, excellent. Thank you. I'm taking note of that. And Gilo testing a new feature and being excited about something that breaks, that means you're on the right track.
Yeah, the Icecast thing. See how many people are actually looking forward to it.
Yeah, no, for real. Yeah, I wanted to do a live demo, but I'm not ready. Let's see though. Maybe yes. Okay, we're gonna try something here, yo. Uh, uh-oh.
Maybe if we get some time for the Q&A, maybe
Yeah,
we
exactly.
do
Let's
something
move on.
funny.
Let's move on to the next speakers. Yeah,
If someone is actually interested in trying things out. And see, the question that went out in the chat was, would there be support for proxying Icecast and proxying Liquidsoap? And I answered, so you're good.
Thank you. Excellent. Yes, reverse proxy is a pain. Well, part of the work here is thanks to Gilou, because Gilou was relaying me all the pain points of Icecast. And I was like, you know what, we could do better. So we're trying to do better.
That's for sure.